Algebra students, Mr. Lawrence here, and we're going to do a solving systems review. I'm going to make it real quick. You guys have been working hard. I am very proud of you. I think there's some really great learning. I know Joan the other day, last week a couple times, you really did some deep thinking and really making connections. So I see that in a lot of people. I see most of you are preparing for class and you're coming in and getting right to work on the formatives and you're thinking, and I think there's a lot of learning going on. All right, so enough about that. Let's not burn too much time here. Remember, we know how to solve the system by elimination. That's where our goal is, to try to either get rid of the x's or the y's. We're going to add the equations together to try to get rid of one of the variables so that we can solve it. Now, in this case, none of my coefficients match. And I remember, I don't want them to match exactly. I want it to be like a -3 on one x and then a +3 on the other. So when I add, they'll cancel out. Okay, but I don't happen to have that, so I can adjust both equations to get it. Well, sometimes I only have to adjust one. In this case, I'll have to adjust both. Now I could eliminate the x's, or I could eliminate the y's. I think in this one I'm going to choose to eliminate the y's, and I'm going to do that by multiplying through by a by a +3 on the top equation, and that will give me 9x plus 12y, and that'll equal 6. All right, so then the second equation, I'm going to multiply by 4, and I'm going to end up with, looks like I'm going to get 20x minus 12y equals 16. And see how the coefficients on y, they match, but they're additive inverses of each other. So now I can add together the two equations, and I'm going to end up with a 29x. Those are going to cancel, and I'm going to get 6 plus 16, which is 22. I'll divide to get x alone. And notice I'm not running to a calculator. I'm going to report my x as 22/29. Is it an ugly answer? Sure it is, but I'm not afraid of it. I know that like 15/30 would be a half. Well, this is a lot more than a half. This can be closer to 3/4, probably a little bit more than 3/4. All right, so now, I'm going to take this first equation here. Wherever I see an x, I'm going to substitute in the 22/9. So I'm going to go 3 over 1 times 22 over 29 plus 4y, and that's 2. All right, so when I do that, I'm going to get 66/29 plus 4y. Now, I'm not going to put a 2 there. Anybody know what I'm going to put? I'll bet Max does. I'm going to go 58/29. Why do you suppose I did that? Well, because I'm getting ready to subtract 66/29 from both sides. So I'm going to think about 2 as being the same as 58/29. All right, when I do that, I end up with the equation of 4y, and that's going to equal, well, 6 minus 8 would be 8, right? It would be a -8/29. I feel like I'm making a mistake there, but no, I think I'm okay. All right, and then I'm going to divide by 4, which is the same as multiplying by 1/4. Well, I know that I can simplify this way and turn that into a 2. Yeah, and that'll turn into 1. And so then y is going to equal -2/29. So the place that they're going to intersect is 22/29 and -2/29. Kind of an ugly answer, but still solvable. Don't be afraid of the fractions. Excuse me. All right. There's a substitution problem. Remember, I'm going to decide which variable to solve for. X in the first equation, y in the first equation, x in the second equation, or y in the second. In this case, it looks like it'd be easiest to solve for y. So I'm going to subtract 3x from each side. I'm going to get 10 minus 3x. All right, well now I take the second equation, but wherever I see a y, I put 10 minus 3x in its place. So I'm going to get 2x minus 50 plus 15x equals 12. I'm going to combine my like terms, get 17x minus 50. Oh, 50, not 15, excuse me. I'd hate for Haley to have to send me another comment that you made another mistake, Mr. Lawrence. So let me correct that before she gets a chance to. All right, and I'm going to add 50 to both sides, right? And I'm going to get 17x, and that's going to equal 62. Well, let's see here. I know that 17 and 17 is 34, and another 17 is 51, and another 17 will give me 68. Well, when I divide by 17 here, I know that 17 is going to go into 62 3 times, because that's 3 times 17, right? Now, I also know that I'm 6 short of a whole, so I think my answer is going to be 3 and 11/17. Yeah, I think that looks pretty good. Now, I'm going to use 62/17 when I do my calculation, but I'm almost positive that that is right. What do I see here? Yeah, I really like that answer. Okay, so now I take x and I'm going to put it in this equation. I think it'll be the easiest one to work from. So I'm going to get y equals, and I know over here I'm going to have 3 over 1 times 62 over 17. Over here I need 10, but I'm going to write it as 170 17ths. Just get a common denominator. I just thought, what's 10 with the denominator 17? 170 over 17. All right, so when I do that, I've got 117 over 17 minus 3 times 2 is 6. 3 times 6 is 18 over 17. And so then y is going to equal negative 16/17. And there's my answer. So we get 3 and 11/17 and negative 16/17. Now, hopefully you can see why we don't like to solve by graphing all that often, because we never know what kind of answers we're going to get. And to be honest, if we graph this, it's going to be really difficult to know that we've put those coordinates on in the right place. All right, but let's take a look at one where we can solve by graphing, because there's a legitimate way to do it. The blue equation, I'm in slope-intercept form, so I'm going to use my y-intercept. And then I'm going to rise 2 and run 1. And so my line is going to be up 2 over 1, up 2 over 1. It's going to look like this. And I strongly, strongly suggest you make your line go forever. It does have to go forever, but really take up the graph, because you're not sure where these things are going to intersect. Okay, let me move that over there. Now in the red one, I'm going to use my shortcuts, and I know that my x-intercept is going to be 8 over 4, or 2, 0. So, got 2, 0. And then my slope is going to be the negative a over b, which is going to be 2 over 1. Oh, look at that. I got the same exact line. All right, that's the same exact line. That can happen. And so the solution to this would be all real numbers. I'm not going to draw the line again. Let me do one more example for you. Okay, here's my last example. The blue one's in slope-intercept form. 1, 2, 3. And then rise 1, run 2, rise 1, run 2, rise 1, run 2. So I'm ready to draw my line. And I'm going to rise 1, run 2. And there we go. All right, the red one. I am going to find my y-intercept, which will be 6 over 2, which looks like it's going to be at 3. And I'm actually could quit now because I'm trying to find a place where they intersect. I know my slope is going to be negative 5 over 2. It's going to go down 1, 2, 3, 4, 5, 1, 2, and up 1, 2, 3, 4, 5, back 2, and there we go. All right, so down 1, 2, 3, 4, 5, 1, 2. And of course I need an arrowhead on this end, and my point of intersection is the solution to the graph, and they're both crossing at the point 0, 3, and there is my solution. All right, Mr. Lawrence signing off. Good night, everybody.